All right. Okay, so the flow is left to right. We're in the product screen. Product screens, we either create new programs or run ones you've already have created. Okay. Let me go back to. All right, here we are. So if you look on the upper right corner, you see the new button.
Yes.
On your machine. There's two types of programs you can run, or there's two styles, I should say, that you can program. You can either start with a picture, a drawing of what you want to make, or if you know exactly what you need, you could just tell it to go to positions. So that's what the language here is saying. Product means you're going to start with a drawing, and you'll let the control help you figure out the way to bend it. You know, what's going to be bend 1, bend 2. Or you could say, I don't need a drawing. Just give me the traditional CNC style. You know, what do I want for an angle? What do I want the back edge? You tell the machine exactly where to go for bend 1, bend 2. So if we look at this icon column here on the left, we have some that have a graphic, like that guy.
Mm-hmm.
That's telling me that we started with a drawing and then we generated a program from that drawing, versus this one here, this 7400 numerical, which just has that little paper icon, whatever you want to call it.
Right.
We don't have a drawing there. If we look under the type column, you kind of see the same thing. The P means we have a program. The 2D meant we started with a drawing.
Okay.
There's a couple I did offline. There's a P, 3D. Same idea. You don't have a P, you're not going to make a dime. You had nothing to run yet. Okay. So, you know, we could start at 4:45 with a picture, and then we could quit for the day, come back tomorrow. It would be a -2T, you know, and would say we haven't finished it, but we got a picture. Okay. So I'm going to go through new product, comes up with first questions, what kind of material and what do you want to call it? All right. It can be letters, it can be numbers, it can be whatever you want. Okay. So we'll call it 77. It has an optional description, same idea, mix of letters and numbers, whatever it takes for you to remember what you're using. You know?
Okay.
Then it's what kind of material, you know, how thick, what type. It calls all this up from a library. These are Delem examples. Are they your material? No. Are they close? Yeah. You know?
Right.
We'll get into that a little bit later.
Okay.
We'll call it steel. This is the approximate length of material along the bed.
Okay.
So we want to know this so that it can calculate how many tons it's going to take to form the metal.
Okay.
Do you have to be out to the gnat's ass like this? No, you can round up. That's all I care. Make sure it knows enough. You know what I'm saying?
Right.
So it doesn't have to be dead nuts at all. Then from the drawing, are we looking at an inside or an outside dimension that you're going to convey to it?
Okay.
This is so it can knows whether it's going to calculate a bend allowance or not. Okay? So 0 for outside, 1 for inside, or just pick the letter. Okay? The next two really have to do with the tooling, but you can tell it up front. What do you want for a bend radius? Okay? If you give it that up front, you could help it choose a different set of tools.
Okay.
Because it's really the tooling that's going to determine this radius, not us, you know?
Right.
Okay. So I always leave it uncalculated, but you can definitely say programmed, and then later on we'll tell it what do we want for a radius. Okay. But I'm going to leave it uncalculated. So you click on accept now, and now you just see a white screen with a blue line and a red dot.
Mm-hmm.
And basically, what is this? It's just pick a flange from your drawing. Okay, so we're doing a silhouette view. That's a 2D. And we're basically just clicking like an Etch-a-Sketch. Okay. So I want to make a top head channel. I'm new, not caught up at this moment what the dimensions might be, you know, but I'd be definitely looking at the drawing, and let's say this was 2 inches. So if I just tap on it again, I can change the length. Okay? Maybe this was 3. Maybe this was 6. We were down 1. And the final one's 2. This little button in the upper right, you kind of zoom out to fit the whole part.
Oh, okay.
Like that. Okay. So this is a side view, which is what they call a profile view of the part we want to make.
Okay.
Okay. Has all 90s. The next step would be tell it what tooling, you know, where it is on the machine. I don't know. How many axes do you have on your machine?
Yeah, I can't remember.
Yeah, okay. So the X is basically in and out.
Yep.
The R is moving the fingers up and down.
All right.
And there's an additional axis, which I don't know if you have or not. They're called Z. It will move the fingers left and right.
Yeah, we have that.
Okay. So this tool setup is kind of cool for you because it'll allow you to tell the Z's where they need to go to find the tooling. Okay. So here I'm in a view. It's the last time I ran this machine. This is the punch and die that I used then. You know, what is it? It's 1 inch opening. It's a little bit too big for 50 thou material, but it'll definitely work. It'll make a big radius.
Right.
As you can see, I can put it here, drag and drop it. It also supports adapters if you have those. Adapters would add to tool height, you know, could be a punch, could be a die adapter. But I'm going to delete this configuration.
Okay.
And then I'm going to say, hey, Delem, why don't you think about it? Okay.
That's cool.
Yeah. So it threw in a much smaller die opening. And it made its length 24 inches, basically to match the length of the material. Okay.
Okay.
It can support segmented tooling. You know how you buy this high-end tooling now, it's in small increments, you know, like 1 inch or 2 inch lengths. You can program that all in the machine. It'll stack it up for you to make a sufficient length.
Can you go back and show us how you did that again?
Sure. So I hit delete. Okay. And then right here is this button called auto select.
Okay.
So it looked at the material thickness basically and said, okay, I'm going to select a die opening based on that. And also looked at the angle and said, you know, I could have tooling that can make that angle.
Right. So like if we have a tooling library of all the tooling we have, it will go through and pick what we need from our library.
Yes.
Okay.
Yeah. Yeah. My library is not your library. Or you can manually select. That's what this add button is. You can go in and say, add what? Punch, die, adapters. Okay.
Okay.
But I'm going to go in and hit auto. Okay. And it threw a punch and a die, and it threw them in the middle of the machine. Did it have to be there? No. I could drag it off to the edge. This made a huge difference to those Z-axis, fingers positions. You know. It's not going to bug us with that.
Okay.
Would it want to work off to the side? No. Will it allow you? Absolutely.
Okay.
It'll even support multiple tool setups.
Okay.
So what I mean is I could add another punch and I can add another die.
Cool.
It automatically chose the same ones, but they don't have to be the same ones.
Really?
So, yeah, I can go in and choose this. Would this be a good situation? Absolutely not.
Yeah, it might have a little interference.
Yeah, we can't beat the physics, you know. If these tool heights work together though, in these pairs, this would be a legitimate thing to do.
Okay.
Right.
But this punch is tremendously longer than this one. This was crashed well before this ever got to do any work.
Right.
I can't beat the physics, but you can definitely add multiple tools.
Okay.
I'm gonna delete that. Delete that. Okay, so the add is where you can manually add things. I can add an adapter. See right there, threw it on top. This
Okay.
might be a good solution to, you know, I had that other punch in here. That was what,
Right. There's some
Oh,
adapters on
I
there.
got you.
you know? Yeah, so using an adapter helps, you know, make the work.
Okay.
All right. So this is just a tool setup screen. Basically, it's us telling it what are we going to use and where they are. Okay.
Okay.
Is it an exhaustive auto select? No, it's not. It's kind of like a first pass.
Okay.
To select on the next button, which is the bend sequence, what you're going to see is a side view of the machine with the part fully made thrown in there. Okay. And I'm going to allow it to go through and look at multiple setups. So now you see, I'll scroll out a bit so you can see it. Basically, this is where it started. It went through and it figured the whole thing. Started from formed and went to flat. The reason it started at formed was it wanted to know right away, can I even make it? Because if I can't do all the bends without some kind of crashing into the machine or the tooling, then
Right.
we know right away we have a problem.
Okay.
So I can repeat that. I can click on new, and it's saying, well, how do you want to do it? You want to manually go through and figure it on your own. You want it to not look at the tooling again, but just look at the bend sequence. Or do you want it to do, you know, come up with the best punch and die again?
Oh, that's cool.
The next one is that on steroids. We would say, not only that, but I also want you to think about, do I need multiple punches and dies? You know, let's say we were making a box. You know, we can't have a 3-foot punch on a box that's only 1 foot wide. You know?
Right.
It would crush those sides. So anyways, it goes through the possible sequence, comes back with the fastest one it sees, most accurate and the safest. Now it shows it flat. Shows bend 1. Before, click on the bend button, you got to see the result of that.
Okay.
Or after. Hit bend again, it'll reposition it for bend 2. Flat, hit bend, it now shows it folded. Again, bend 3, 4, after. Then the final bend. Before and after. There you go.
Very
Very cool.
neat.
Very cool.
Click on save. It just wrote a program.
Okay.
Awesome.
Now you can run. So from right here, we can immediately go into the run screen and we can make this.
Okay.
Let's say there was some things about the way it did this though that we didn't like. It's probably information we should tell it. So I'm going to go back to the drawing screen. Let's say this flange here was a critical flange. Even if the blank size varies, I want to make sure I hold a 3-inch. Okay. So to do that correctly, I really need to gauge off of one side or the other for both of these hits. Okay. Otherwise, there's a risk that the variation, the blank size is going to show up here.
Okay.
So there's a button here called properties. So I have this flange highlighted. Click on properties. Down here in the bottom is this word precision. There's 3 possible choices. Normal means just as important as all the others. High means more important. closing means less important. Okay,
Okay.
so if I tell it high, I'm telling it of all these flanges, this is the one I want you to make sure you can guarantee 3 inches.
Okay, that's cool.
Okay. So if I go back to bend sequence, you can see right away, it's like, well, what we currently have ain't gonna do it. I'm gonna go back and show you one other thing that will help us kind of follow this. There's a button here called marker.
X2, you do what Jeff does?
It's like putting a sticker on the material.
Okay,
You can put it on any one of these flanges you want. I'm gonna put it on this one. If you look real close, it's orange on one side, purple on the other.
mhm,
So it can help you sort out what's the top of the material and what's the bottom of the material. It could be important if you use material has that film attached to it. Yeah. Or in my case, I'm reusing it more to make sure I know which one of these is 3. In fact, I'm going to put it directly on 3. So I'm going to clear it,
Right.
going to set it again, then choose the flange. So now I put it right on 3. Okay. So
okay,
now when I go back to my bend sequence, you can see here it is here. It's
Okay.
already told me beforehand that I'm not going to make this the way that guarantees the 3. Let's look at the current setup. So this was bend 1. So far, so good, you know.
right,
Here's bend 2. No problem yet. Any variation of blank should be over here.
Uh-oh.
But then when I do this one, I can't
Morning, Bill.
guarantee it because you're holding that flange. I'm really guaranteeing this flange. So that's the issue.
Okay.
And then finally, the last thing. I'm going to go through and I'm going to allow it to do this again. Okay, so now it has a different solution. You can see they're all green, so it's not complaining. Here's bend 1. Bend 2. Any variation is out here somewhere. Here's bend 3. Here's how we guaranteed it. We gauged it right there.
okay,
So now the variation's out here somewhere. The variation's going to be right there.
okay,
So that's one way for you to manipulate the bend order in order to achieve a guaranteed result.
okay.
Now, don't go fooling yourself thinking, gee, if I make all these high, no, no.
It's gonna be a perfect part, right?
Yeah, exactly. So like we had the high, you know, I'm going to go pick on this again. There was a way to tell it purposely park, gauge it in a way that if the blank does vary, that variation ends up here. So now it makes that look red, kind of orange today. Go back to my bend sequence, you can see, hey, you know what? That ain't gonna achieve what you want, but just go new, sequence only. Now let's see how it gauges it. Bend 1, bend 2, the variation's out here somewhere. Now the variation's here.
Gotcha.
And there it is. Purposely
Oh.
parks it. So drastically different solutions
Yeah.
to achieve a bottom line, which was guaranteeing a blank.
Right,
That's great.
that's cool.
Okay. It also looks at this as handling time, and that's time it takes us as operators to manipulate the part. Get to that a little bit later, but you can see it throws an estimate up here. Do I ever care about the accuracy of that? No, not really. I look at it as a way to bias the kind of moves it does, whether it's a top, bottom, front, back, or a twist, which is a combination.
Okay,
That's more about me, you know,
right,
because I know you guys have a preference. You know, they're real long parts that are skinny. You know, you don't want to spin it. You don't want to tip it. You want
Right.
to flip it, you know, particularly have a part support on the front of the machine. You know, you could rifle through this in no time. Okay. But we'll get to that. The next button over program shows us what it wrote. Okay. So you can see we got a graphic, follows along with where we are in the bend sequence, bend 1 to bend 4, a tool setup. But primarily I'm in this screen to look at this, the numbers it generated. Okay. It never asked us for any of this. Okay. The core of it is the angle and the back edge position. Okay. So somewhere in here is the angle right there, 90 degrees. All this other stuff was where it was in the machine, which is big deal for the Z's. How far it went up after the bend, the opening, how many tons it calculated, how long it held it in the bend to release the pressure, how much distance, and what speed the ram moved. Things, you know, these are defaults to me, you know.
Okay.
This side of it's more important to me, you know, where the gauge is to do this. You know, it's got my imaginary machine has an X1, X2. It's got an R1 on 2 and then a Z1, Z2. So, and you could see this for just one bend, whichever one I want, or there's a button here called all bends. Show it like a chart.
Oh, okay.
Okay. So I find this one more useful. You know,
Right.
Yeah.
You know, where's my gauge position for all these hits? And you can see I could edit these immediately if I wanted to.
Cool.
I probably wouldn't though.
Right.
Let me
Right.
change my machine to look like a real machine for a second so I can show the auto button. All right, so the service one. All right, now I got my auto button. So you see the program here on the left. Notice how it's all grayed out, which means you
Right.
can't make a change from this screen. But then this right column is where all the corrections could be put in.
Okay.
And angle correction for Y1, angle correction for Y2, back edge correction for X1, correction for X2, and then some global, which they call general corrections. Like if the material varied 2 weeks from now,
Gotcha.
you could put in the different. Since we're doing all 90s, you know, say each one needed a 4-degree correction, that had put in 4 times, I can put it in once right here,
Oh, that's cool.
and it'll apply to all 4 hits.
Okay.
Let's say the back gauge was off 20 thou. It's off that for every bend. I could park it here. Okay. So general applies to all bends. It doesn't matter which one I put it in.
Okay.
It's going to be there for every single one.
Okay.
Don't get caught chasing your tail. What do I mean by that? Well, I put a positive 4-degree correction here. I put a negative correction in the individual, you know, -4. I just canceled it out. I did nothing.
Gotcha.
Okay. So you can double down. You know, I can put a correction here. It'll add to whatever corrections down here.
And that would be on whatever step you're on. If you're on
Yeah.
Okay.
Yeah. This top stuff is only applies to bend 1.
Gotcha.
Generals for everything else, for all.
Yes.
Okay.
General goes to all of them. Yeah,
Okay.
exactly. Okay. Questions on that?
Nope.
Okay. So I'm in the auto screen. I can run it like this, or you might say, you know what? I don't want to see any numbers. Just show me the picture. Okay. We could twist this if we wanted to.
Oh, that's cool.
Yeah. I can't program a 3D part, but I have a 3D view of the machine. Okay. You can see that little sticker we put on there,
Oh,
Okay.
okay.
purple and orange. Okay. That could be a big deal to start off. You know, if this is some intricate blank with writing or, you know, not just film on it, the
Right.
sticker could be a big deal. Yeah, exactly.
Yeah, they're gonna-
So this 3D view, why do we have it? Well, it's all about looking for crashes, collisions with the tooling, with the RAM. You know, typical machine has scratches all over the RAM. How did they get those scratches,
Yeah,
Right.
right? Yeah.
Exactly. We got a
Now,
few
the
parts like
control
that
will
now.
let you run it that way, but it's gonna, it's gonna badge you about that. It's gonna say, hey, Jerry, it's crashing,
Right,
because it doesn't want it to happen at all.
right,
But we know sometimes you can't make a part unless you allow that to happen.
right.
All right. So Ben 1, Ben 2, Ben 3, zoom in a bit. This one better have a retract.
yeah,
Right.
yeah.
I'm sure it programmed that. And the retractors get the bar out of the way so that this part can
Right.
flip up. Okay.
Right.
And you can see this one here, it actually did a thing called a lay on.
On time.
So we turn that finger from being a gauge to being a gauge and a support. Okay.
How do you do that?
Well, the way we do that is if we go back to Ben's sequence, there's a button here called assignment. It's abbreviated. Okay. And if we look under back gauge possibilities, the first thing is when will it have the freedom to do it? Now, so it's described as a dimension,
Okay.
and it's roughly 6 inches. So at this dimension, 5.9 and beyond, it has the freedom to do that.
Okay.
So it'll automatically pick it when it thinks this is a good idea. How
Gotcha.
you would do it is you would select your fingers. So in this case, I'm going to select this button here, which is all about moving the fingers.
Okay.
Okay.
So I'm thinking.
I'm going to change my view back to. This does not allow me to move the fingers in this service screen. So just give me 1 second. All right, here we are again. Go back to Ben 3. Is that the one? Yeah. No,
With 4.
it was 4. Thank you. All right, so here we are. Select my finger. I can move it in and out. And where's my guide to move it back and forth? I know it's here. Go back to the side view. Maybe it's be easier there. Ah, there it is right here. So
Okay.
in your view, see this little icon right here?
Right.
Mhm.
It's going to go through all the possible candidates. That was a bad one.
That's cool.
So it chose the gauge there. I was kind of hoping it was going to want to gauge up here. It doesn't. It could be because the travel of the R doesn't allow it to go up that high in my
Okay.
imaginary machine. But this button is like a step.
Okay. So if you click it, it'll change.
Yeah.
Step by
It
step.
knows it has another step here in the back. That's what it's trying to do.
Oh,
Notice
okay.
it made the finger look red because this is not a good way.
Right, right. You're gonna have interference.
And it's saying that so many different ways,
Right.
but it was a choice. So we
That's
could have
cool.
gauged it this way. I would imagine in your machine, you have more freedom for the R. Could have gauged off the back, this right here.
Right.
It tries to limit how many bends it's gauging from to the one we want to do.
Right.
Because it
Right.
knows if our angle's wrong on this and our angle's wrong on that, then this flange is going to vary. you know,
Okay.
it's going to drift.
Right.
So it's all about trying to minimize that too. And we'll talk about that a little bit more. So questions on that?
No, that's pretty cool.
Cool. Ah, there we go. So this button right above it,
Oh, okay.
and if you look, it shows one that the R is a little bit lower
Right.
or even or back down there.
Okay. That's really cool.
Yeah, so you'll have these buttons on the side. There's another button above it. This guy right here. It's going to pivot these two flanges like that.
Oh, okay.
And you can see it complained right away because we told it, hey, man, park any blank variation here. Well, right now it's going to be parked over there. So it turned that red for that reason.
Oh, that's cool.
I'll do it again and it'll come back with that message. Does not comply with closing dimension. This is a completely different program though, you know? So if I hit save, I just rewrote the program supporting this gauge position.
Okay.
Still a 90, the angle didn't change, but the back gauge position sure did, you know?
Right.
Here it had the lay on, here
Right.
it doesn't.
Okay.
So here we programmed the 4-bend part using graphics, okay? I'm gonna go back to products. And I'm gonna write a new one without a graphics. So that's called program. Same idea though, you know, what do you want to call me? Here, we can also change the way we describe the ram position. We can tell it an angle, which is what that symbol there is, or we could just tell it a stroke, a number, without a clue, you know, with no clue what angle you're going to get out of it. Okay.
So that's going to be help. See, we got we do a part that's a curling die, and so there's not really a set angle. You know, we need to know how far the stroke's going to go. So is this how we would do that with the absolute?
Yes. If you wanted to describe it as a number, yes.
Okay.
It would be something I would experiment first in manual, because manual will show you both the ram position and the angle you use to try to generate that position. Okay. I'll jump to that in a little bit.
So one quick question.
Yeah.
So this die we've got, it's a big monster die. It's huge. And I don't know how we would ever program it. If we do it with the absolute, would we have to have it in the program or programmed in the machine in the library, or could we just stick it in there and run with it?
You got to show it something in the library.
Okay.
It won't allow you to run with no tooling.
Okay, so it's a big block. I mean, it's basically forming a bucket. If we just did a big block, would it accept that?
I don't know. I'd have to see more about it.
Okay.
Before I could answer that.
Okay.
But is it like a hemming tool or is it like a channel?
Well, it's like it's not just a die. It's actually kind of like a press with springs in it.
Okay. Okay.
It's a forming die.
Okay. Yeah, we'll cover tooling and then we'll talk about there is some tooling you can program with springs in them,
Okay.
which are made for hemming.
Okay.
It's a 2-stage tool. It's like one
yeah,
will do a sharp angle and then you put it in the side and squeeze it. Yep. Those will have springs in them.
Okay.
And it knows those springs are going to compress, you know, so far. And you could describe how far that will compress.
Okay.
What is it doing with that is it's telling it where to go, you know.
Okay.
So, okay. So I'm going to leave it on angle. And again, you know, what are you running for material? Maybe this time it was aluminum. Now, what's the difference with the material choices to the machine? Well, how many tons it's going to meet? That's based off of the material property called tensile strength. And then how much spring back it's going to have.
Okay.
And that's what they call E modulus or elasticity.
Right.
Okay. So when we get into the material library, you'll see those two columns. Click accept. Same idea with the tool setup. You know, what do you want to use and where do you want to put it? After that, notice it copied the last one we had. Okay, but if we need to change it, here's the screen where you change it. How do you change it? Well, you highlight the one you want to change and pick on the name and it brings up the library. Yeah, you pick the one you want. Okay.
Cool.
Now, if I click on the program button and notice the drawing and the bend sequence buttons are grayed out.
Yep.
Because there is no drawing. Okay. Click on the program and now it's saying, okay, for bend 1, what do you want for an angle? 90. Recalculated the force. I can look at it like a graph form like this, and I can say, you know what, a 5-inch flange, copy the 5 to X2, or I can do it in the main, which is only about bend 1. Okay. Where do you want the fingers? Where do you want the Z's? You know, maybe this one I wanted at 59. Yeah. It'll adjust both based on that bend length.
Okay.
Right now we'll say 8. Watch the fingers. If I say it's like a 12, it's going to move those fingers to bridge the material. I'll change it to a 12. Highlighted these to tell me, hey, I moved those fingers left and right to better gauge a 12. Yeah. So basically just program what you need to. If there's another bend, this button here on the right edge is lower, add
Right.
bend. Click on that, made a second one, copying everything from one without changing anything.
Gotcha.
Okay. So if it's still a 90, but instead of a 5, it's a 15, just do that, you know.
That's
There's
cool.
another bend. It's going to copy 2 into 3. Same idea. Just go in and say, you know what, this is an 8. So I don't care, you know, what screen you want to program, and you could do it in the grid form, all bends, or you could do it in the individual one.
Okay.
But there's no picture. Okay.
Okay.
Cool. Questions on that?
Nope.
Okay. It will support the fingers being supports in this manual screen, well, in this program screen. So the button right there, shift gauge. So here I can say, you know what, I wanted that 8 to be 8
There we
made
go.
this way. Okay.
Yep.
Still going to get your 8, but the back edge position changed dramatically. You know, it moved in.
Okay.
That was a 2-inch flange, excuse me, 2-inch ledge on that finger.
Right.
The gauge would have went to 6.
So
You know,
it'll
this was
automatically figure that out for us. We don't need to enter anything if we change it from to lay on the finger
Yeah.
instead of, okay.
Yep. There is a setup for the finger. We have to make sure we describe it to the control,
Okay.
how thick it is, how long it is. Otherwise, you know, these values would be way off.
Right.
Cool. So you can see the back edge position is no longer 8. It's now 6.8189.
Gotcha.
To support that. If we look at the R column, we should see it drop down. Okay. Okay. There you go.
That's cool.
Yeah. Gonna go to the settings screen. This is kind of like a default library. First question is inch or metric.
Well, and that's the question I've got for you. 'Cause I see you're running everything in inch. And
Uh-huh.
so when they came in and installed the machine, they told us it had to be run on metric. Is that true or false?
You can make it inch anytime you want.
Okay.
So much easier.
Yeah, because so right now, everything we're doing, we're having to convert everything over to.
No.
Oh, okay, awesome.
Nobody makes money in millimeters, okay?
Okay,
Yeah.
okay.
There's
Well,
only
we're
one thing I know in metric, and that's 2-liter Coke.
gonna- Yeah, so we'll be switching to inch then.
So go ahead and go to settings. It's the first question under general. Make it inch.
Okay, awesome.
All right. There's other things in here. What language? You can get lost in that. You know, there's a ton of choices. Don't go looking for trouble. It has a manual built into it. That's what this help button's all about.
Okay,
It's got multiple languages for the help. It's got a different keyboard layouts. Why, I don't know. Don't go. And it got a little beeper that you'll never hear. And then you can describe when it beeps, what it does. And it's got this thing called the command panel. It's this little upper right corner little area up here.
okay,
I look at that specifically to see status or state. Because I want to see, is the light guard pissing off the machine?
right,
If you have a light guard on this machine and the light guard gets pissed off, it will not pass on the foot pedal signal to the control. You'll step on the pedal, nothing happens.
right.
And you're always
Yes.
thinking it's the control's fault.
And that's
Well-
where it'll show us what's wrong.
Yeah. So there'll be a little status readout up here and it'll have a number from 1 to 6. 1 means idle. So if you step on the pedal and nothing's happening, look at that. If it says 1, then you know it's the light guard or something else.
Okay,
It's not the control. Coming down, it should be a 2 for fast, a 3 for slow.
okay,
If it doesn't have a 2 or 3 in it, it doesn't know you want it to come down because the guardian's pissed off.
okay.
So you got to correct that. And that's really the part that gives me the most headache about a guard is you never really know what do you got to do to make it happen.
Right,
Next tab under settings is materials. Okay. These are Delem defaults. They're not what you're buying, but they are close. Okay. So there's 3 columns here. Tensile strength, and it's in tons per inch, not tons per foot. Okay. Spring back, again, tons per inch. And then a new thing they just brought out about a year ago called strain hardening. You can leave strain hardening blank because I don't know much about it, but it will definitely influence the radius that it thinks the material is going to roll out.
okay,
So tensile strength is important because it's how many tons it's going to calculate to do the bend. Spring back is how much is it going to want to return back to the way it was before you hit it. Okay. So I don't know the correct numbers for the material you're buying,
right,
but I would hope the guy you're buying it from it does.
right,
You know, it should be a data sheet.
okay,
You should be able to find tensile pretty easy. E-modulus is harder because it's a formula, but there should be 2 of the parameters on the data sheet, and there's some formula that calculated. But I do know that these numbers matter. You can see stainless is going to take a lot more tons
Right.
to bend than
right,
you know steel than aluminum does.
right,
So it's all about, you know, how close you're going to be on that first hit. That's really what this is saying to me. And will it do it at all? You know,
okay,
it has room for more than these 4 materials. It can go up to 99.
holy cow.
So if this stuff matters to you, you can definitely program in your material.
Okay,
You know, the name is just a label.
Right.
These 3 column settings that are making the difference. Okay. All right. You do have the ability to back up tools, backup parts. Get in the habit of doing that routinely in case lightning strikes.
Right.
Okay. Program settings is some behaviors. Angle correction program copy. What does that mean? That means if I put a correction in the Y1, it'll copy it automatically to 2
Okay.
because it wants it to be square, not
Right.
a tapered bend. But there's choices where you could say, you know what, split the difference, kind of pivot in the middle. I don't know why you'd want to do that, but it's somebody paid for that. Or you could say, you know what, if I put a change in 1, don't do anything in 2. Pretty much, I think the only one you really want to do is copy. Okay. If you had an X1, X2 package, same idea on that. If I make a correction on X1, copy the same correction to 2. Just one thing to keep in mind, you continue to go down the column and you make a change to Y2 or X2, it will not copy upstream. So what I mean with that is if I change Y2, it won't change Y1.
Gotcha. Yeah.
It rolls down, you could say. So just keep that in mind.
Okay.
In the manual screen, do you want me to show Y1, Y2 positions independently? Yeah, that only applies to the manual screen. Recomputation of numeric values. What that's saying is, hey, if I do something, let's say to the Y position or a die, let's say I change a die. And it impacts a bunch of things like a bend allowance, a Y position. Do you want me to recompute things that it impacts? And right now it's on. So it'll automatically go through and change everything it needs that, your one change impacted. The off would highlight things that should be changed by you, but it won't do them.
Okay.
Gotcha.
So in my world, I would say leave that on. Less for you to think about.
Yeah.
If it ever gives a case where, it's doing that and you didn't want it to do it, this is where you would go to turn that off.
Gotcha.
I know we're covering a lot of stuff. Keep in mind, I treat settings as like do it once and then don't think about it again.
Right.
Like defaults. Okay? We don't have a serial port, so we don't have to worry about machine ID, but that's a network connection thing. Defaults. If I don't have a reason to raise the RAM, how much should I raise it? So this is really in your programming.
Okay.
Just giving it numbers. How far up do you want the RAM to go after the hit?
Right.
So this is kind of like for all new programs. So you can go ahead and say 2, because maybe you'd like it to go up high just to give you lots of clearance. You could tell it's something it probably can't do,
Right.
It does have travel limits, so you can program this beyond that. And all we're going to do is make it go to the travel limit.
Okay.
Okay. Pressing speeds, I don't know what your machine is, but it, definitely can do 0.3, probably do 0.7. Faster is not always more accurate.
Right.
Okay. Retract, wait for retract. What's this about? We back the gauge up to allow the material to fold.
Mhm.
Do you want it to sit back there a little bit longer than normal so that you can get the part out and rearrange it for the next hit?
I got you.
Okay. And this is a default. So this is kind of like, yeah, I want you to do that all the time, or no, don't do it all the time. When I need it, I'll do it just for this bend. Yeah. Default when to move the back edge to the next position. And UDP means all the way up, upper dead point. Default delay time, default dwell time. If I'm doing a hem, what's my sharp hit at? These are defaults. It's just going to throw them in, versus forcing you to answer all these questions every time you program a hit. Default, am I outside or inside for a drawing? Okay, if you're an inside shop, choose inner. Then any new programs you write from here on out will pick inner to start with.
Okay.
Doesn't mean you can't change it to outer. We're just saying, hey, we're just trying to get it closer to the way you want, so we're not forcing you to answer every question.
Right.
Default material. Maybe you're a stainless shop.
Gotcha.
You don't have to remember to pick stainless all day long. Okay. Radius, we talked about that. Computation. If I'm writing programs with numbers, do I want them to calculate bend allowances? Okay. How do I want them to do it? Do I want Delem to do it based on the formula that they will not share? Or do you want to tell it, which is what a table is,
Okay.
where you can go in and tell it with this material, this thickness, this angle, this tooling, I needed this much correction.
Oh,
Yeah, that's kind of cool.
Yeah, I'll put it all in your hands.
All right.
Okay. So I don't know how much, bend allowance is going to be a pain in your butt, but if it comes to the point where you're, dissatisfied with the Delem answer, make a table.
If we do that in this screen here for a certain material, like 11 gauge, every time it does 11 gauge, it'll automatically.
Yes.
Oh, okay, that's cool.
Yeah. And there's a way to do it through the auto screen that's even easier, because it'll fill in a lot of the questions it was asking. It'll know what material, it'll know what the angle is, it'll know what the tooling was. You just give it what the correction was.
Okay.
Yeah, so it's even easier in the auto screen.
Okay.
But it'll build up this table, with all their setups, all your materials, and these angles and what the correction was.
Okay.
Cool. If I give it a program, no drawing, do I want it to think about bend allowance correction? It's kind of like a yes or no.
Okay.
Off means it's thinking inside. On means it's thinking outside.
Okay.
The cool thing it'll do with this correction is it won't change the dimension you program. If you put in 3, let's say, it won't put it into 3. It'll put it in the X correction.
Oh, okay.
So you got the visibility.
Cool.
You also have the ability to change it. If I wipe it out, I just made that a 3 inside.
Okay.
Because it'll throw in a negative correction to make it an outside.
All right.
It always thinks airforming. So this next one is, if I told it I wanted to hammer this, which is what we call bottoming, how many times do I need to multiply the tonnage? 3 times. So let's say it was a 10-ton airform. If I switch that to bottom, it will now be 30 tons.
Oh, wow.
Okay. Bottoming would be the case where I'll throw a position in to stop it just in case, but it doesn't expect to get there. It expects it to stall on tonnage. Okay. Yeah. So it'll set the valve to 30 tons. It'll watch you step on the pedal, watch the ram go down and stall. It'll hold it there for like a second, then it'll return it.
Okay.
So that'd be a case where you got, 89 degree or 90 degree tooling,
Okay.
Okay.
That's cool.
What the-
We have 90-degree tooling. It's kind of a pain getting through 90.
Yeah, old style tooling, exactly. The Z distance is where do I want the fingers to gauge to the material. So let's say I have this book is my material.
Yeah.
0 means gauge right on the edges.
Okay.
I said 1 inch, I'm telling it index in further in
Oh, okay.
by that amount.
Okay.
So that's what that's about. So kind of influencing the gap between the fingers based on the material width.
Okay. That's cool.
The production is just about the valve. Again, it's airforming. So what we're saying is, hey, whatever you calculated to do the airform, give me 20% more.
Okay.
Because airform, I'm going to some dimension, really, even though I told it at an angle, it calculated to some position. And I just need to get there. You know, whether I had 10 tons programmed in there or 50, still going to the same position. So what we're saying is, we're going to give you a little bit of fudge factor, 20% more. This is out of the box. So, and it's really in case, let's say, the material is a little bit different than what we know. You know, that's what that fudge factor is about. Make sure we have a little bit more than enough to get to the job. So you can influence it. You know, if it stalls out and you're like, yeah, you know what, 120 wasn't enough, you can put 160 in there. Now it'll do 60% more. All right. Probably won't be an issue. Of all the years I've been doing it, I've only seen two customers play with this.
Okay.
But it's here, so I'm going to cover it. But it's not something, you know, I'd be thinking about. This next one is time. So the control looks at safety, number 1, accuracy, number 2, then speed, number 3. This is where it knows the speed. This is time it takes us as operators to handle a part. So the top thing is 3 dimensions, and they're really widths across the machine. Small, medium, large. Yeah. I threw these numbers in, you know, 1/2 foot, 3 feet, 100 inches. It's the time chart below that that really matters to me. Okay. And we're talking about 3-part handlings. The top, bottom. Yeah. Top, bottom.
Okay.
The next one is front, back. Yeah. Front,
Right.
front, back. So I'm flipping like this. So the first one I was doing this, top, bottom. Next one is I'm pivoting. Versus the last one, combo, twisting.
Okay.
I'm talking about it to you because I know you have a preference.
Right.
You may not realize it, but you do. All I'm telling you is if you have a preference that's strongly about, you know, top, bottom, make that time the quickest to it.
Okay.
I've made combo be the preference to it. You know, top, bottom on this first one was 1 second, front, back 1 second. Combo, I said, was no time at all. Is it really 0 seconds? No, it's just something. Do I really care what it is? No, I really don't. All I've got out of this was convince the machine to try to do combo turns in all dimensions,
Okay.
whether it was small to medium, medium to large, large. That's what I really use this for. I don't care about the accuracy of the time. If you do, get your stopwatch and, you know, fill it in.
Right.
So if it forms something in a way you're like, that's not the way I do it. It's probably because out of the box, all of these are identical.
Okay.
You know, yours is going to look like that. So it's going to, whatever one that comes across first, it's going to take.
Okay.
As you told it, all these are the same. You know, wouldn't know. You know, you might be the kind of shop that you do long, skinny things, and you don't want to do that. You don't
Right.
want to do that. So if it's doing that, it's pissing you off because,
Right.
yeah, not how I do it, you know? So this is the place to go to manipulate that, to do it the way you like to do it. Okay.
Right.
And again, it's only about time. You know, if there's an accuracy thing, this doesn't matter anymore. You know, it's going to pick it based on accuracy over time.
Okay.
And the next thing, it's got a clock. If you're worried about time, go ahead and I know out of the box, it's probably not the right time.
Yeah.
I care less. I don't even look at it. Okay. So that's what the settings was all about. The
Okay.
heart of it for you was really this inch metric.
Okay.
Everything else tailored for new programs to be more like you want them. You know, particularly like what material we wanted. You know, inside, outside, things like that. The rest of it, ignore. You know, unless it's doing something that's really ticking you off. You know, why is it always saying aluminum? Well, somebody made it say aluminum. Machine, important screen. This is where your tooling library is. For punches, which are the upper tools, and dies, which are the lower tools. So a tool to us is really a couple things. Number one thing to us is the height of it. Okay. Number two is the graphic silhouette of it, which it uses to see, can I do what you're asking it to do? Can I do a 90? You know, can I do a 30?
Right.
Will that flange come back and crash into the tool? You know, that's what the graphic silhouette's about. The height is really where do I have to go for the work to begin? Okay.
Okay.
There is a side view of the frame. You know, if you want to change the view of it, here's where you go. Do you need to? No. Here's where adapters would be programmed. You know, I don't know on your machine if you have multiple adapters or not, but if you did, this is where it'd be.
Okay.
Hey, we talked about that finger being a support.
Oh.
This is where we program that geometry of it.
Okay.
So if you look down here, this pretty picture is like a side view of a finger.
Right.
And this finger happens to have 3 gauging locations. 0, the first one,
Yeah.
one we think about. 1, the first step. And 2, a second step. So for each of these, we need to know these dimensions. FL would have been how far in does the finger have to come to do the change from 0 to 1.
Okay.
H1 would have been, hey, how far down are we going to drop? Or excuse me, FH would have been, how far down are we going to drop to support on step 1? Okay. That's what this edit button is going to bring up.
Okay.
All these dimensions. So you're going to go out there with your calipers.
Yeah.
If you care. You could do more than 3. You know, you could say, well, you know what? I have another one. And now it's just 2 more dimensions you got to program.
Okay.
You know, or you say, I don't have 3, I have 2. You know, you need to plug in these dimensions.
Okay.
You know, this is an Ermac machine, right?
It's, I'm not sure. It's one of the Trump generic brands.
Generally, those guys pre-program the fingers, but I would double check.
Yeah, it's a JFY.
Yeah. You might have one that has a pretty little graphic showing the top view of the finger, you know, the
Okay.
claw, or whether it has a dowel pin on the front of it.
Okay.
round surface. So those are imported in as a DXF, but you
Okay,
still get them. I would still verify this geometry.
okay,
And there's a graphic of the side view of the RAM. Y, collision detection.
okay,
None of these numbers change where it's going to go for a bend. It doesn't look at this for that at all. Okay. So if there's a case of, you know what, it's always saying it's crashing when it's not, it could be that the drawing's not accurate.
okay,
And that'd be a reason to go in here and modify it.
okay.
We covered just about everything for a first pass.
Okay.
So let's go to punches. Let's say we have to add one. I have a bunch of here. This is a demo machine. I'm going to program a new one though, new punch. So I click on new and it's asking me two things. What do I want to call it? This is what the ID is. And what's the initial shape to use? There is a hem, which is a flattening. There is one that's spring loaded. It would be the air plus hem. The spring wouldn't be in the punch, the spring would be in the die.
Right.
But here you see it's got that sharp, and then it's got that flat where we would do the hem afterwards. And then there's also this guy, which we call a big radius, a big bull nose. Okay. So you pick the one that's closest. Notice there isn't one here called a gooseneck.
Right.
So a gooseneck would be a standard that we would then change in the drawing. So I'm going to call it me. So it doesn't have to be numerical. If your tooling has laser marks on it, and has a catalog number, I would put that in. There's no confusion. So I picked that, and now it's asking me a big deal question. The height of the tool. Okay. This is not the total height. This would be the height from the shoulder to the tip.
Okay.
So, let's say there was some little nub up here, the tang,
Yep.
the clamp. I could care less about that. I want to know the part that meets the shoulder down to there. Yeah, that's the height I want to know.
Okay.
A lot of times nowadays, tooling's marked, which is awesome. Back in the old days, it wasn't. You were forced to either find the catalog or go measure it yourself.
Yeah. A lot of ours is older like that, and we luckily we got some of it wrote down though.
Yeah. So you're going to have to go measure it, it sounds like.
Yeah.
So let's say this was 4 inches. Next thing is, hey, what's the angle of that punch? That's important because it needs another limitation.
Right.
Maybe it's 85 degrees. And it wants to know that tip radius. That's important because that's going to be the bend radius, right?
Right.
Say that's 0.06. Now it wants to know the width of that initial knife edge. And we'll say it's 1 inch. Another important question, how many tons before something bad happens?
Right.
It's tons per inch, and it's really, really low because Delem has no clue. So they're going to throw something in there ridiculously low.
Right.
It can barely bend cardboard. If you leave it at this number, it's going to badge you all the time.
Okay.
Now it's going to say punch resistance is less than, the tonnage it needed to do the bend, something like that.
Right.
What is the right number? I don't know. Your tooling provider should know, or should be marked, or,
Right.
you should know from experience and the rusty old stuff. I
Right,
guarantee it's more than 0.86, you know.
right,
Typical is like 2 to 3 tons.
right.
Say 3. Hit accept. Now it's this drawing screen. It throws the knife edge in. Everything else is a dotted line. And the dotted line means, hey, it's up to you to put in the side view.
Okay.
Okay. So right now it's showing it. I'm going to make this a gooseneck, so it's not going to be 0.73 on each side.
Right.
I'm going to go ahead and I'm going to change the right height. I want to do it from this screen though. I want to, there. So I clicked on the number.
Uh-huh.
And let's say this gooseneck was 1/4 inch on the inside. All right, it did a goofy thing with the dotted line, but ignore that, okay? The critical thing was, you know, I took my ruler, my calipers, and I measured from the center to the inside edge of the gooseneck, and it was 1/4.
All right.
Another thing to keep in mind when you're looking at a drawing of a punch, you're standing to the left side.
Okay.
Okay. So it's like we're looking down the barrel from the right side of the machine.
All right.
Okay. So all I'm going to do now is I'm going to adjust what I need to. Maybe this was, yeah, this we'll leave alone. This actually went straight up, you know, the front side of the gooseneck. Do I have to fill in all these dotted line dimensions? No. I could click on auto finish. Notice it made it solid.
Right.
It plugged in the dimension for me. But the inside of the gooseneck, I have to fill that in. So all I'm doing is I'm just dragging and dropping, looking at the angle, looking at the dimension. You know, maybe we measured that and it was 110 instead of 111. Just click on properties,
Ah,
make that 110. Yeah. Change this dimension. Maybe it was a little bit longer. Properties again. Maybe it was 0.375. Something like that. Not done though. So if I get back on that, if I click again on the drawing, get off of this, it's highlighted on that. Okay. Get my dot back here. Now when I click above it, notice it filled it in again. Do it again.
that's cool.
Like that. It's up to you how accurate you do this. You know, a lot of the goosenecks nowadays, these are radius,
Mhm.
you know. If you want to put a radius there, click on that angle, click on properties, notice there's a radius. Yeah, maybe it's got a 1-inch radius. Look at it now. Now it's round
wow.
looking. Yeah. Yeah, exactly.
That's cool.
So it's what's important to you. I'm a bottom line kind of guy. I got the rudimentary shape in there and I'm done and I'm using it, you know. So now I describe the back of that gooseneck, what was cut away. This, I'm not done though. If you see there's 2 dotted line guys,
Mm-hmm.
I don't need to fill those in. It can do that for me. All I need to do is click on auto finish until everything's solid line.
Okay.
Once it's a solid line, all these dimensions are locked in. Okay. All these angles are locked in.
Okay.
In order to change one of these, I have to delete a solid line that's connected to it. Okay. or start over. Sometimes it's easier just to start over than
Okay.
trying to modify one of these. So this little screen in the corner here allows you to manipulate it. The reason we're manipulating it, is it what we wanted? Do I look like that? Questions on that?
No, that actually answered a lot of questions we already had.
Cool. Okay. It's going to take practice. You're going to get lost with those dotted lines. I guarantee it. Just keep in mind what you really care about is where you're working at the moment. So, you know, when we were down here and it had that goofy dotted line coming down to a corner, it was just trying to connect all the sides.
Right.
You know, do I wish it didn't do that with the dotted line? Yeah, I wish I left it blank, you know, but it doesn't. Okay, let's do a die. So I go to the die library, click on new, same idea, all different shapes, square. Here's my spring loaded guy.
Ah, okay.
There you go.
Springs will be right down in here.
Cool.
Here's one that's I've never seen, but they make it. Here's, you know, typical four-way. We're not going to describe all four sides of the four-way, but we could describe the two on the top side.
Okay.
Something even more elaborate. I've only seen one of these. This little notch section on the front would be where you could do that hem. Door frame hem. I've never seen this. I don't even know how to use it. And then these multiple piece dies, which have this rotating, this pivoting shoulder here. It's called a wing band.
Yeah.
Roto Die is a manufacturer of that.
Yeah. Yeah.
Yeah. It's a whole bunch of questions. Fill all that in. So I'm going to pick standard. Same idea. You know, what do you want to call it? Some critical things here. You know, how wide we are. That's a big deal to the back edge. You know, where am I going to crash into tooling? And height. You know, how far down does the rim have to go to do the work? You know, say 2. And we'll say this is 1.5. Shoulder radius. Yeah, how much the V opening is going to change by? 0.06. Angle. You know, what can you get out of it? Keep in mind, it's going to evaluate every punch and die you choose against each other. So let's say, you know, I programmed this as a 30-degree.
3 loaders, splitters.
That gooseneck I did was what, 85? It would not be happy trying to use these two together.
Gotcha.
Okay. It would be okay with the opposite combination, though. If I had a 30-degree punch and an 85-degree die, it would allow that.
Okay.
But it does not want this to become a log splitter. Okay.
Yep.
So it's going to look at that, and that would be a deal breaker. So I'm going to go back and say, you know what, this is an 85. And then what my opening is. Delem would say be half the radius. I find that's a pain in the butt to try to figure out. So I typically do the full radius. You know, so what my opening is with the radius to the flat. You know what I'm saying?
Right.
I find that easier. I plug that in. It does influence the angle, you know, how far in it thinks it's going to go, but not that bad. And we'll say this is what, a 1/2 inch, something typical. And then the bottom, what's the shape? The standard is the V, but it knows there can be something with a round on the bottom. Here you can see it's so deep down that there's this little channel that you probably don't have. But if I change what that bottom height is, I can make that go away. You know, I can't beat the physics though. It has to support it. Another one is it's square on the bottom. Okay.
We wouldn't need
Gonna leave it at standard. And the same question we had before, how many tons per inch? Click accept. If it's a square thing like this, you're really done. You just gotta click auto finish to all those dashed lines look like that. But maybe it's something that, you know, it's got something like this.
that will always be down. So
So all I'm doing is I'm adding sides. I'm making it wider. Yeah. Maybe this one was square,
that is a line.
something like that. Cool. So it's like an etch a sketch. All I'm doing is filling in the side geometry. Does any of that change where it's gonna wanna go to do the bend? No.
Here's the problem. Well, here's
It's
the-
gonna judge that off of this
Okay.
spool height. Then it's gonna judge it off what we had for an opening.
Stays like that.
That's the two things that really matter. All this pretty picture stuff is just for collision detection.
Okay.
You know, if the part comes around, will it hit the die? Okay. Questions on that?
Nope.
So I know it looks complex, but you play with it, it'll become, you know, something you'll be able to do.
Right.
Yeah.
And then don't feel like you have to be exhaustive unless something you're making requires that, you know. You do have a lot of collision,
Right.
you know,
Well,
and you want to know everything about them.
This is already
If
explained
it's-
a lot more than we understood before. So.
Yeah, yeah. We don't have to fill in every single void and bump on a tool, you know. Okay, there's one dash line left. Click auto finish there. It's completely done. If I tried to leave without it, it would have said, hey, you know, there's something you missed. Do you want me to auto finish it? And if you click on yeah, I would have filled in anything we missed. Okay. Tool properties. Remember I talked about segments?
Uh-huh.
Yeah.
You know, if you, there's a tab here called segments, segmentation. This will be where you can fill in your library.
Okay.
Hey, you know what? I have a 2-inch piece. I have 6 of those.
Pretty cool.
Yeah,
Let's click add again. I have a 5-inch. I have 3 of those. I have a 24-inch or a 25-inch piece. I have 1 of those. Okay.
Okay.
So that's where the segmentation is.
Okay.
So later on, when you say, hey, I have a part that's 30 inches wide, it's going to come into this chart and say, okay, I need to build a 30-inch wide die. I can do that by taking the 25 piece and a 5-inch piece. I'll put them together.
Okay.
Okay.
Cool.
Is it a deal breaker not to have that? No, absolutely not. Would it make a more accurate representation of it? Yes. You know, if it doesn't know, it'll just make up a 30-inch one. You know, you may
Right.
not physically have it, but it's going to throw it in there. So if I go back to here and I get rid of you, I just change you, and I look for the one I just made, me, and I go to segments and I hit compute segments. You can say, oh, you know what? I don't have one that works for you.
Ah.
You know, it's trying to marry a 25 with a 24. What it's trying to say, I don't need a segment. I got my 25, you know.
Gotcha.
But if it could, you know, it would have computed it. Questions on that?
No.
No? Did we cover enough stuff for you to go out and play on the machine?
Oh, yeah,
Definitely, yeah.
yeah, we've learned a lot today.
So here's what I recommend. Is, typically we sit down and we go through, like in your case, you've been using manual, you haven't done auto.
Right,
Auto supports anything that's in this product library.
Okay.
I would grab a couple of your simpler parts, and I would start programming them in.
Okay.
You've been watching me here for about an hour and a half, and I make it sound pretty easy, but
right,
it may not be easy for you when I'm not there with you.
right,
So I recommend you go through trying some of this.
okay,
Don't be, pissed off if you get stuck. Just
right,
write down what's happened.
Right.
We can reconvene either again later today or whenever.
okay,
And then, we could go through it again. You can ask me your questions, whatever makes sense to you.
okay. Well, I'm sure at some point, I'm sure I'll have Jeff maybe email you or send you a picture of
Absolutely.
that one
Yep.
die that I was talking about, and maybe you can get us a little bit of a, maybe an explanation of how we would go about, putting that in.
Uh-huh. Okay. Yeah. And particularly take pictures of it, what it looks like, include that in the email.
Okay, awesome.
But basically, I do remember now, we were talking about, we wanted to do a position. That's right.
Yeah.
Let's go to main. This is this 3-bend part I manually created.
Okay,
There's a method bend by bend. Okay. Let's see, I was looking for. Okay, it won't allow me to choose it there, but I could have chose something like hemming,
Uh-huh.
which it thinks it's flattening. I could have chose bottoming. Either one of those choices, it does not care about the angle anymore.
Okay,
It's throwing a position in that you can edit. The number it threw in was more than enough. The punch and the die should have married even if there was no material in there. And this is beyond that. Basically, with the y-axis, the bigger the number, the further it comes down.
okay,
Okay. So when I was talking about, hey, I would use manual mode. I'm going to save this real quick just so I can go to manual mode. I do that by making an imaginary machine. Here's my manual button. Let's say this is the punch and die we have in there. So let's make it something we just made. The me and the me. Here we are. Back to main, this upper right button. And we'll say it's highlighted with the X because it knows it's not nearly as long as that. We'll just say we're 6 inches. And what do we got for material in here? Steel 034. I would start with a 180. Okay. Because what's 180? 180 is I just pinch the material. I kiss it. Whenever I program new tools, I always ask for the 180. The reason is I'm checking the heights.
gotcha.
If the height's wrong on one of them or both of them, it won't start to bend in the right spot. If it's shorter than I told it, it's going to leave a gap. If it's longer than I told it, it's going to start bending it. Okay. The 180 is going to tell you something big, though. It's going to tell you this y-axis position. Where do I need to go to pinch the material? It says 11.9.
Okay,
Okay. Versus a 90. 12.1.
Okay.
So you can use the manual to kind of give you a sense of, hey, what position do I need to go to try to do work?
Right.
Whether it's a piece of urethane die or, you know what I'm saying?
Right. Right.
You're trying to find enough depth to do it. Okay.
Basically giving us a starting point.
Yeah. And once you know this number, hold on to it, write it down
Right.
when you go to your program, and you can plug that number in right there.
Gotcha. Cool.
Yeah. Yeah. So you can overwrite that number. All right. Well, I'll be available
Okay.
whenever you want to get back together.
Okay.
And like I said, email or text, whatever you need to do to get a hold of me.
Okay.
Awesome.
Okay.
Thank you very much.
Yeah, thank you.
Hey, it was great working with you guys. All
Thanks.
right. We'll catch you later.
And bye.
All right. Bye-bye.